Welcome to map projections. This is just an introductory explanation as to why you've got to get your head around map projections if you're going to be doing any GIS application. So what a map projection is this actually is a map projection, this heart shape over here. So it looks distorted, but the Earth, which is geoid in shape, if it's going to be represented on something that is flat, it's going to be distorted. And that distortion is called a map projection. I've embedded a very good YouTube movie over here. It's about 8 minutes. Please watch it, thanks to Mango Map. And why I really like it is because it actually explains, they've got two different buffers, and they actually explain how a circle can be distorted if you happen to have the wrong map projection. So over here, this diagram over here shows the geoid shape of the Earth and what it would look like if it was projected on a flat sheet of paper touching the Earth, if it was a party hat, or if it was a cylinder, piece of paper wrapped around the globe. So that is what the end product would look like. So you'll find that the flat one, we call this methyl projection, conical projections, and cylindrical. But we're going to be concentrating on the cylindrical projections for today. So picture a light source. If you happen to have a wire globe with a light source and a globe in the middle of the globe, and it's actually projecting the light out, hence projection. This particular projection, which is the Mercator projection, you can see that everything is true where there's less distortion where that cylinder is touching the globe. Here it happens to be the equator. And as you head further north and south, so you're going to get greater distortion. So what we are going to be looking at here is a type of cylindrical projection. So, but however, instead of having the cone, the cylinder wrapped around the globe like this, what we are looking at is a cylinder wrapped around it in this fashion over here, which will touch a meridian. And all places that are very close to that central meridian, that's what we call a central meridian, is going to have less distortion. And as you go further and further away, east or west of the central meridian, so you're going to have more distortion. So what in South Africa, we are looking at what we call our coordinate reference system, which is the particular reference system which we are going to be looking at. We look at a Mercator type of Mercator projection, which we call Zangi. Now, the name ZANGI comes from ZA for South Africa, and NGI stands for our National Government Information Services, and they're the custodian of all our topographic data. So what they do is they've projected South Africa with these different central meridians, and they happen to be at odd numbers. So I want you to picture it as if it's a slice through South Africa like this. And then all those, if you wanted to get any topographic map at within this region over here, within this rectangle or this slice over here, you would then choose a central meridian. In this particular case, I think this happens to be 27 degrees east. If you're in Cape Town, you would choose 19 degrees east. In Durban, obviously it's a little bit more to the east, you would choose 33 degrees east, and 31 if you happen to live in East London. Now, why this is important is within a GIS, if you are going to be doing a buffer, which is what you're going to be doing for your task, you have to put in the correct coordinate reference system. So you would write in the top here when you do your search, Zangi, standing for ZANGI, and then for Johannesburg, choose number 29, click OK, and that will give you the correct projection for your particular map. This happens to be a map that I did for friends of mine that live in Franschhoek. They wanted to know what their 5-kilometer buffer is going to be. You obviously are going to choose your house, so you're going to be saving a vector data as a point in the middle, and then choosing a 5-kilometer radius. If your buffer zone doesn't look like a circle, then, as I've said over here, if it's not a circle, you have got the wrong projection. So it's very important that you choose the right projection, but you can easily go back and change it. But what might be useful is actually have a digital version of this once you produce your map on your phone, or print it out. So if you are stopped by the authorities, you can simply say between 6 and 9 that you are well within your rights to go and exercise within this buffer zone. You give them your address and you can impress the authorities with your exercise map.